We know we can generate a solution to this problem in 7 pores, and so we're wondering if we can do that in less pores. So what we're going to do is see how many possibilities we have and then explore every one of them. So if we're going to do this in 7, 4, 5, 6, 7 things, then there are 6 possible moves each time. In other words, we could go from the 8 to the 5, from the 8 to the 3. We could go from the 5 to the 8, the 5 to the 3. We could go from the 3 to the 8, or the 3 to the 3. So there are 6 things, 6 pores we could have with each one. So there are 6 times 6 times 6 times 6 times 6 times 6 times 6, and 6 to the 7th power is an astounding 279,936. And we're going to list all of them and make sure that we can do this in 7 or less. And actually see if we can do it in less than 7. So let's get started. First of all, we're going to eliminate some of them already. We know we have to start by either going 8 to 5 or 8 to 3. Because we can't go from 5 to anything or from 3 to anything because there's nothing in the 5 or in the 3. So knowing that we go from 8 to 5, if we start there, then we're going to write this like an ordered triple in order from 8, 5, 3, like the largest, medium, small. So if we pour from the 8 to the 5, then we're going to have 3, 5, 0. And if we pour from the 8 to the 3, we're going to have 5, 0, 3. And now we're going to explore every single possibility. With each one of these, it's going to split off into 6 things, but let's be realistic. We can't pour from the 3. We can't pour from the 3 to the 5 or the 3 to the 8. And we can't pour from the 8 to the 5. We just did and filled it up. And it would be illogical to go from the 5 back to the 8, because then we'd be working backwards and we're trying to find the fastest possible way. So that's not going to work. So let's split this thing off and let's explore the only 2 possibilities that we have with this. There's one, there's the other. And one of them is going from the 8 to the 3, which puts us at 0, 5, 3. And the other one is going to be from 5 to 3, which is going to put us at 3, 2, 3. Now, as we know, this one is the solution. This is the path that's going to take us to what we think at this point to be the shortest solution. So let's go. Let's just go ahead and finish writing the whole thing. 1 pour, 2 pour, 3, 4, 5, 6. We're going to run out of room, but we'll deal with it. All right. So we pour from the 5 to the 3, then we pour from the 3 to the 8, giving us 6, 2, 0. And then we pour from the 5 to the 3, giving us 6, 0, 2. Then we pour from the 8 to the 5, giving us 1, 5, 2. And then we pour from the 5 to the 3, giving us 1, 4, 3. And then we have one more pour. We'll swing it around this way. And it's from the 3 to the 8, and it gives us 4, 4, 0. So let's use a little bit of logic here. Anytime in the process of going through this and making this enormous tree that's going to be ridiculous, if we come across one that has the same pattern later, then it's not the most efficient way and we can stop it. All right. Also, again, there's no need to backtrack. So we're really not going to do 270-some thousand of these. There are no possibilities that we can do from here, because if we went from 3 to 8, we'd be working backwards. If we went from 5 to 8, let's do that real quick. If we go from 5 to 8, then we're going to have 5, 0, 3. And 503 is not the most efficient way, because we can get to 503 in just one pour. So already we know that's not the most efficient way. For the sake of time, I won't bore you to death, but I've completed a chart of all the ways that you can do it. The things that I've marked out in green, hopefully you can see it on the camera, the things that I marked out in green are the ones that won't work, or that we're backtracking, or the ones that were repeated earlier, that were a repeat of something that happened earlier. For example, this 350 happened earlier. And because it happened earlier, it's not the most efficient way. So following all these paths gave us, after 7 pours, it gave us something that was not a solution. So even though this may lead to a solution, and actually it does because it's the same thing here, it's not the most efficient way. So 7 pours is the most efficient way.